Hello friends, thank you for watching my channel again. And this is our agenda. We'll talk about projectile motion. And don't forget to subscribe my YouTube channel. It's very important for me because you have already supported my YouTube channel. And then don't forget also click bell notification because I always update the video about physics and mathematics, everyone. This is our learning objective. Identify and explain the properties of projectile, such as acceleration due to gravity, range, maximum height, and trajectory. Determine the location and velocity of the projectile at different points in its trajectory. Apply the principle of independence of motion to solve projectile motions problem. And this is our supported materials. So we can use the simulation to explain about projectile motion. Friends, this is our supported material. Now here, we also can see many quantities in the projectile motion. First, you can adjust the initial speed using the simulation. You can start from 0 speed and then maximum is 30 meters per second. And then you also can adjust the object, or we can say the projectile, starting from cannonball until car. And then you also can adjust also the mass of the object. So maybe you can costume it. You can use the second simulations in lab. And then you can also put the air resistance here. And then you can see the velocity vectors and then its component, the velocity, and the total velocity, and then the component of accelerations and total accelerations. You also can adjust the height of the object, for example, like this. And then you can put slow motion. Now here, we assume there is no air resistance in this simulation. And then you can also click component velocity because that's very important for us to analyze the projectile motions formula. Friends, before we continue, I will take a note here to make sure there is no missing concept in this video. Now, before we continue, we are talking about the projectile motion. I only give you the simulation for the projectile motion. Let's say I will set up the initial velocity be 8 meters per second. And then I use the cannonball or the golf ball because mass is less than the other. So 0.05 kilograms and the diameter also 0.04 meters. And then there is no air resistance here. Let's try to see the path of the projectile motions, everyone. I also set up the initial velocity again with the same angle. And then one more. All right. Now here, everyone, the angle of elevation can be adjusted. We can put theta here. All right. Now, based on this demonstration, what is the meaning of projectile motions? So based on the path of the motion, so projectile motions is the motion of an object projected into the air. Again, the projectile motion is the motion of an object projected into the air. And then you also can see the type of curve or the type of path of the movement of the projectile motion. And then the object can be used, is called projectile. And the path is called trajectory. Now, I just want to recall about the concept of kinematics, because that's very important for us to analyze the motion of the falling object. In kinematics, we have one-dimensional kinematics, right? And the motion of the falling object, as covered in problem solving basic for one-dimensional kinematics, is very simple. But it's different from projectile motion. Projectile motion, we can consider that the motion is two-dimensional motion, or we can say two-dimensional projectile motions, as long as we can put there is no air resistance here. And the most important fact to remember here is the motion along the perpendicular axis. Which one is the perpendicular axis? This one. If we put the component of velocity here, we can fire it. So that is very, very important fact to remember, is that motion along the perpendicular axis, everyone. Let's see. For example, this one. So the motion along the perpendicular axis are independent and can be analyzed using vector. So we can analyze separately. So that is why we can say projectile motion is kinematics in two-dimensional motion. As introduction for you, there are two types of motion in the projectile motion. First is the vertical motion, and then the second one is the horizontal motion. So the key to analyzing two-dimensional projectile motions is to break down into two motions, one along the horizontal axis and the other along the vertical axis. And the choice of axis is the most sensible. Why? Because the acceleration due to gravity is vertical. Thus, there will be no acceleration along the horizontal axis. When the air resistance is negligible. So we call the horizontal axis is the x-axis and the vertical axis is the y-axis. I will try to analyze using the component of vectors. We know there are three components of motions that very important to analyze. First is velocity. Second is the acceleration. And the third is the displacement. Of course, to describe motion, we must deal with the level of the three quantities. So we can decide that the level for the initial velocity is VI. And the unit of the initial velocity is in meter second minus 1. And the final velocity is labeled by V. And the unit is in meter second minus 1. The acceleration due to gravity is denoted by A. The unit is in meter second minus 2. And the displacement Vx and x also have two groups. The first one is the final displacement. So the final displacement dx and the unit is in meters. Xi is the initial position or displacement. And the unit is in meters. So we have already deal with the component in projectile motions. Now, we must to find their components along the x and y axis. And then we can put V1x or Vix equals to the initial velocity along the x-axis. Vx equals to the final velocity along x-axis. Viy is the initial velocity along the y-axis Vy is the final velocity along the y-axis. So we have already dealt this one. And then the component of the accelerations are then very, very simple. The acceleration due to gravity along the y-axis is negative 9.80 meters second minus 1 minus 2. So then we can put Ay is equals to minus 9.8 meter second minus 2. And there is no acceleration along the x-axis. So means Ax is equals to 0 meter second minus 2. Ay is called the gravity is in vertical because this is constant. Now here we have revealed all levels, and then we try to review the kinematic equations. So the kinematic equations can be stated into some formulas. First is x equals to xi plus v vector t. And v vector is equals to vi plus v over 2. V equals to vi plus 80. X equals to xi plus vit plus 1 over 2 80 square. V square equals to vi square plus 2a times x minus xi. So we have already dealt with this kinematic equations. And this is a common kinematic equations. So we can use the kinematic equation to solve or to state the formula in projectile motions. Now, we will go back to our simulation. Let's see. So, from here, I want to adjust the initial height of the object be 0. And then again, we can assume the angle of elevation be theta. So then we can put the component of velocity vector and the total. So we can adjust the initial velocity or speed here. Now, you also can see there are two components of velocity. So we can start from the initial velocity. Now here, we can put the arrow to analyze the initial velocity, for example, like this. Now, please consider the white arrow. So the white arrow be the initial velocity. So we can put Vi. And then there are two components of initial velocity. The first one is the horizontal component and vertical component. Now we have already deal with the level of the quantities in the projectile motion. So the component along the y-axis for the initial velocity is V Iy. And then the component of Vi along the x-axis is Vix. Now, let's try to move this projectile. So now, we also can see from the demonstration that if we stop the projectile at t seconds, we can see the final velocity and its component in this demonstration. Let's say, if we stop the object at this point, or the projectile at this point, for example, the time taken at this point is t seconds. And this one is the final velocity, and final velocity has two components. The final velocity along the x-axis and the final velocity along the y-axis. Now here, we can try to describe or resolve or break the motion into horizontal and vertical components along the x and y axis for each component. Now here, we can start from the initial velocity. So break the motion into the horizontal and vertical components along the x-axis. Let the angle of elevation be theta. So we can put Vix equals to Vi cos theta. Viy is equals to Vi sin theta. For the final velocity, we also try to resolve the motion into the horizontal and vertical components along the x and y axis. So Vx equals to, so the angle depends on this. So this is the angle. So Vx is equals to, but the angle can be different, right? Now we can put the angle is alpha. So Vx equals to V cos alpha. and Vy equals to V sine alpha. You also can find the magnitude of Vi from this process. So Vi is equals to square root of Vi x square plus Vi y square. So this is the magnitude of the initial velocity. If question need you to find the angle of elevation or the initial angle, you can also use the formula tangent theta equals to VIY over VIX. Same thing like final velocity. So the magnitude of the final velocity is V is equals to square root of Vx square plus Vy square. And then tangent alpha is equals to Vy over Vx. We can say this process is the first step to analyze the projectile motion. And the second step is treat the motion as two independent one-dimensional motion, one horizontal and the other vertical. That is step number 2 if you want to analyze the projectile motion. So step 2, we try to treat the motion as two independent one-dimensional motion, one horizontal and one vertical. So then we can put the horizontal motion first. For the horizontal motion, Ax is equals to 0. We can see from our appointment, Ax equals to 0. So we can use the formula of the kinematic equations. So then x equals xi plus vxt. And we know on the horizontal motion, and there is no acceleration here, we can also see from the kinematic equations that v equals to vi plus at. Vi plus at, and there is no accelerations. So then vx equals to vix equals to vx. Why? Because ax equals to 0 and velocity is constant. Now you can change vx becomes vix. So there are two formula there. So then x equals to xi plus vix times t. We can also simplify x equals to xi plus vix is vi cos theta times t. We assume that xi is equal to 0 meters. And then the result is x equals to vi cos theta times traveling time. So this is used to find the range of the projectile motions. How to find the range of the projectile motions? Let's see from the simulations. So the range is starting from the initial position to the final positions. That is range of the projectile motions. Now we continue to analyze the vertical motion. That is in still step 2. Now we assume that positive sign is for the object is going up. And then negative is down. Now, in this position, because we know the vertical motion has the height, the new quantity, we cannot put x later, so we can put y. So y is the final height equals to initial height plus 1 over 2 VIY plus VY times t. And Vy equals to VIY minus GT. Y equals to YI plus VI y times t plus minus 1 over 2 GT squared. Vy square equals to VI y square minus 2G y minus YI. You also can see the component or the direction of the acceleration due to gravity from this. Let's try to check. I will try to adjust the angle again, everyone, and the speed increases. So which one is the acceleration due to gravity from the simulation? Why? The acceleration due to gravity is negative because from the simulation, this is the direction of the acceleration due to gravity. We have already assumed that negative sign is for downward, means the acceleration due to gravity is negative. Now, from this simulation, which one is the final height? So the final height can be measured from the final position to the ground. So this is the final height. And the initial height is starting from the original point. And this is the initial height. You also can adjust the initial height. But here, the initial height is 0 meters. Step number 3, if you want to solve a problem in projectile motion, is solve for the unknowns in 2 separate motions. One horizontal and one vertical. Note that the only common variable between the motion is the time t, means the time taken or the flight of time, it is the same for vertical and horizontal motions. And the problem-solving procedures are here the same as for one-dimensional kinetics or kinematics. And then you also can solve this problem in projectile motions. And step number 4, try to recombine the two motions to find the total displacement S and velocity V, because X and Y motions are perpendicular. And we can also determine these vectors by using the techniques. And then we have already write down the vector formula before. So we can use the vector addition or vector subtractions, or we can say the analytical methods. And we also can find the magnitude of VI and the final velocity or V. And then also the angle of the direction or the angle of the movement of the particle or projectile. Now, step number 4 is use the vector analysis. Use the vector analysis example if you want to find the total displacement. So the total displacement is S equals to square root of X square plus Y square. So Y square is the height, and then X is the range. So that is the total displacement. Now from the simulation, I will show you which one is the total displacement. So the total displacement start from the original position to the endpoint. So we can call this is the displacement or S. How to find S? We can find the range, or we can say X. And you also can find Y, or the final height. And then you can find the displacement of the projectile. Now, how to find the direction of the movement of the particle? You can also use theta equals to inverse tangent y over x. Same thing like the velocity. So the velocity or the final velocity, for example, here is Vx, and then Vy. So we can find the final velocity is V equals to square root of Vx square plus Vy square. And then you also can find the angle of the final velocity, or we can say theta V equals to inverse tangent Vy over Vx. Now, everyone, if you try to make the movement of the particle step by step, for example, starting from the original position until this, we can try to break down or analyze two-dimensional projectile motion by breaking it into two independent one-dimensional motion along vertical and horizontal axis. For example, like this. Starting from the initial position and then continue. This is V and its component V, X, and Vy. Continue. This is the final velocity also at this point. This is Vx and Vy. And same thing like this. Until reach this position. Now, the time taken is different. If you want to find the final velocity, you have to know the time. Let's say this is at t1 seconds, at t2 seconds, and then at t3 seconds. Here at t4 seconds. So the speed or the final speed of the projectile motions can be different, depends on the time. Now, so the horizontal motion is very, very simple. If you break down this motion into vertical and horizontal axis, we can try to break down the motion in the horizontal axis like this. So this is the motion in the horizontal axis. So the graph is like this, starting from the original, continue this, and the last one is this point. So this is the horizontal motion. And then for the vertical motion, we can also see from the simulation. So we can draw the path of the motion in vertical axis. Starting from the ground, for example, like this. Continue. And then at a certain point, the particle or the projectile will go back to the ground. And you also can see the different value of the velocity on the vertical axis. So they have different values based on the length of the arrow. And same thing like when the projectile is going back to the ground, for example, like this, and then starting from the initial velocity on the vertical axis, and then you can also see the length of arrows are different. So then we can see that is the velocity has different values at instance of time. Now, so that is the condition for the projectile motion, guys. You can set up any simulations using this website. You can set up also the initial height of the particle, and then still follow the formula. Whatever you set up in the simulation, and then later use the formula, so we can find the unknowns. And then please follow 4 steps, and then you can also solve the problems in 2-dimensional motion, or we can say the projectile motions. In the next video, I will give you the problem related to the horizontal and vertical motions or projectile motions, everyone. So don't forget to click bell notification, because you can get the update from our channel. Thank you, everyone. Bye bye, guys.